Welcome, everyone! So today we're going to stare right into the face of a mathematical monster, and we're actually going to solve it. Get ready, because we're about to tackle a problem that looks totally unsolvable, but you'll see it's hiding a beautifully simple secret.
Okay, let's just dive right in. Look at this thing. This is our challenge, a massive 10th degree polynomial. Our mission is to find the single value of x that makes this whole, intimidating expression equal to 0.
I mean, seriously, just take a second. If you saw this on a test, what would you even do? It feels like trying to find one specific grain of sand on an entire beach, right? Well, that's the mystery we're unraveling today.
So yeah, let's formally meet our monster. The goal here is simple. We need to find its root. Now, a root is really just a fancy word for the solution. It's the one number you can plug in for x that makes the whole equation balance out perfectly to 0. The way I like to think about it is, this equation draws a super complex curve, and we're just trying to find the exact spot where that curve hits the ground. Now, you don't fight a monster with your bare hands, right? You need a special tool, a secret weapon, and, well, it just so happens we have one. We're going to use this really specific method to analyze our polynomial. Let's think of it like a machine, okay? We feed the numbers from our equation, the coefficients, into a special formula. It's going to process them and then spit out a whole new set of numbers that reveal the polynomial's hidden structure. So here's how it works. It's a three-step process. First, we take all those coefficients, the numbers in front of each x. Second, we plug them into a specific formula that, helps us see the relationship between an equation's roots and its numbers. And third, the formula calculates a new value for us, which we're just going to call s. Let's see what happens when we run our monster through this machine. And this is where our detective story really kicks into high gear. Because when we start turning the crank on our little machine, the clues it gives back are, well, they're honestly kind of unbelievable. Okay, first run. We process the first couple of coefficients through our formula. The output is 0. A nice, clean, simple 0. Interesting. Okay, let's feed it a few more. All right, for our second run, we use a few more coefficients. The calculation is a bit more complex, but look at that. The result is exactly the same, 0, again. So at this point, you really have to ask yourself, is this just a coincidence? Or is the monster trying to tell us something? Could this be the one critical clue we need to crack this whole mystery? And would you believe it? The pattern holds. We keep running the calculation for every single set of coefficients in that ridiculously long equation, and the result? 0. And again, 0. And again. Every single time. Without fail, the output is 0. This is definitely not a coincidence. This is a profound pattern. So what does this impossible pattern of zeros actually mean? Well, it means we found the monster's secret weakness. It's time for the big reveal. So here's the secret. The math behind our machine shows that these s values we calculated can be used to build a way simpler, but totally equivalent equation. And since every single s value we found was 0, it means our huge original polynomial is mathematically identical to something much, much simpler. Which means our entire beast of a polynomial just collapses. All that complexity, all those big numbers, it was all just a clever disguise for this. X minus 1 to the power of 10 equals 0. The monster was just a really simple expression wearing a scary costume. And now the solution is crystal clear. What value of x makes this equation true? Well, if x minus 1 to the 10th power is 0, then x minus 1 itself has to be 0. And the only number that works is 1. That's the root. A single, simple 1 was hiding in there all along. But you might be wondering, wait, how can a 10th degree polynomial have just one answer? It's because of a cool concept called multiplicity. It just means that for this specific equation, the answer 1 is so fundamental that it actually counts as all 10 solutions rolled into 1. The curve just barely kisses the ground at x equals 1 and then turns right back around. And, that kind of leaves us with a final thought. We started with what looked like an unbeatable monster and found this simple, elegant truth hidden right inside. It really makes you wonder, doesn't it? How many other things in the world that seem impossibly complex are just hiding a single, beautiful rule right underneath the surface?